Can you hear me, Nicole?
We can hear you, Tony.
Thank you.
Hello, everybody.
Hey, Nicole.
I am working on promoting our Oversight Committee members to panelists. And then we will get started at approximately 10:02. I also want to make sure that we have our translator available. So if you are joining us and you are here to provide translation for the meeting, please raise your hand so that I can make sure we get you promoted as well. Okay, I have sent the invitations to promote all of the members of the Oversight Committee I can see online to panelists. If you have not accepted that, please accept that so we can get you here on the panelist side of the webinar with us, and then we will get started. Okay, and then just a reminder, if you are joining us today and you are here to provide translation for the meeting, please raise your hand so that I can get you promoted. Okay, I just have one invitation remaining out there for one of our Oversight Committee members to join as panelist. Ben, if you can hear me, if you can accept that, please. And apologies, everybody. We are just waiting for everyone to join, and then we will go ahead and get started. Okay, if everybody can bear with me for 1 second, I am just going to check on our translation services and check on our last member of the Oversight Committee and get them here on our panelist side. So Ben, I'm going to try something. Can you please let me know if you can hear me? And I want to see if I can hear you now on a setting that I've changed.
Yeah, now I can hear you. It gave me
Okay,
an unmute thing.
I don't know why it is not allowing you to join as a panelist, but
You want me to
while we conduct
log
the
out and log
meeting,
in, or?
we can try that one more time. And if not, what I will do is if you raise your hand during Oversight Committee business, I will make sure to unmute you and allow you the opportunity to speak. That'll be my workaround for today.
Hey, Nicole,
Okay.
looks like he is now a panelist.
Only temporarily because I have done the unmute, but it was not
Oh.
allowing him to join as a full panelist. Thank you, Michael.
Got it.
All right,
Okay.
I'll leave and try to jump back in, see if it works.
Thank you, Ben. And while I am waiting for Ben to join us back, if there's any other members of the Oversight Committee who have joined that I have not promoted to panelist yet, please raise your hand so I can get you promoted to panelist. And then again, I'm going to do a last call for our translation services so that I can also get you promoted to panelist.
Hello, I will be the Spanish interpreter.
Okay, great. Thank you, Daniela. I will get you set up for the interpretation services.
Thank you.
Nicole, when I logged in on my phone, for whatever reason, it allowed that, so I'll just do it off the phone.
Okay, wonderful. Thank you. Okay, good morning, everybody. Thank you for bearing with us as we navigated through our technical difficulties this morning. We will now officially begin the Oversight Committee meeting. So I'm going to go ahead and bring up the agenda for today. While it looks like a short agenda, we do actually have a lot of items that we are going to be discussing. So I'm officially calling to order the MRC Oversight Committee meeting. We will start with our open issues. I wanted to provide an update on the risk assessment report, and then I'll turn it over to Scott for an update on the safety culture review. So on the risk assessment report, a public comment period was held for 45 days in September. And we had a public meeting also in September. The purpose of that 45-day public comment period was to allow an opportunity for a presentation of our community risk assessment results to the community, and for the community to be able to provide comments and have questions addressed. We have compiled all of those questions and comments from that 45-day public comment period and meeting, and have been working with our contractor TRC to provide responses. We are looking at having those responses incorporated into the risk assessment and having a final report out on that report on February 22nd at the Industrial Safety Ordinance Community Warning System Ad Hoc meeting, which is February 22nd from 1 to 3 p.m. And I will work on grabbing an agenda for that and making sure that that information is posted to our website so that people who want to see the final report of the risk assessment will be able to join that meeting. Okay, Scott, I'll turn it over to you for an update on our safety culture review.
Okay, thank you, Nicole. So the culture project is indeed underway. We did send 2 separate requests for documentation to the refinery, and I think most of that has been provided to the extent that documents are available. We were supposed to have been on the site with our site work last week, but unfortunately, I got bit by the COVID bug, and so I wasn't able to come out. So now we're trying to reschedule a new date for the site visit, and I know Ken Axe is on the line here, and I'll just put the date out, a proposed date out of March 5th. It would be the next time that both Ken and Stevic and I would be available to come out to do that site work. I think everything is going as pretty much as we expected so far. We just need to get on the site and do that part of the project.
Great, thank you for the update, Scott. Okay, before we move on to our new business, are there any questions from the Oversight Committee on the status of either the risk assessment report or the safety culture review?
Sorry, Nicole. Can you just reiterate one more time when the final report is due, where the public can see it?
For the community risk assessment report?
Yes.
Yes, so there will be a report out on February 22nd at the Industrial Safety Ordinance Community Warning System meeting, which is from 1 to 3 p.m. And I will ensure that we get that information posted on our website in the MRC page.
Thank you.
Mm-hmm. Tony, I see you also had your hand raised.
Yeah, just wondering with Scott, why it's going to take another month before we start to actually get on site. Is that a problem with scheduling, or is it the fact that you guys have a problem with your scheduling?
No, it's definitely on our side in terms of other work that we're doing.
But just to provide some clarification, Scott, while you may not make it on site until March, you have already begun work on document review. Is that correct?
Oh, yes. We have the documents. We are continuing to review them. We're putting together our protocol. So yes, we're continuing on that work.
And just one other follow-up, what's the expectation for on-site? Is it a week? Is it 2 weeks? Is it a month? Can you clarify that if you can?
Yes, it would be 3 days. We've put together a schedule that we should be able to complete in 3 days.
Great, thank you. Ken, I see you have your hand raised as well.
Yeah, just a reminder that the CalARP ISO audit is still ongoing and scheduled tentatively not to complete until March 7th.
Thank you, Ken.
Mm-hmm.
Okay, if there are no further questions from the Oversight Committee, we will go on to our new business. Our new business for today is that we will be having a presentation from Scott Berger on the incident investigation root cause analysis report. I do see that we have a hand raised not on our oversight committee. Just a reminder that there is a public comment period at the end of this meeting where everyone from the public will be able to speak for 2 minutes. So I ask that all members who are not panelists, please hold their comments and questions for that point in time. Before I turn this over to Scott for his presentation, I wanted to just kind of go through the process again of where we are at today. So Scott has been working on doing the incident investigation root cause analysis of the spent catalyst release. He has developed a report which has been sent to the Oversight Committee for review and comments. Today is an opportunity for Scott to also present out on those results to the Oversight Committee and for the Oversight Committee to ask questions and make additional comments. While we will be having public comment period today from all of our members of the public, we are going to be hosting a separate public comment period for 45 days, very similar to the risk assessment. And that is when we will address all comments from the public on this report. The intermediate step in between this is that any comments from the Oversight Committee will need to be incorporated into Scott's draft report, and any changes that may need to be made to the report based on Oversight Committee comments will be made before we start that public comment period. I will go into a lot more detail about that at the end of Scott's presentation, but I just wanted to kind of explain what the purpose of today's presentation was and set that expectation for our Oversight Committee members. So Scott, I'll turn it over to you for your presentation, and then we'll go over into our Oversight Committee comment and question period after.
Okay, thank you, Nicole. Let me get my screen shared. Okay. Hopefully you can now see the presentation on your screens. Very good. Okay, so as Nicole mentioned, what we're going to do this morning is give a summary of our independent investigation report. I think just based on the space available on slides and based on the time that we have available, we're not going to get into the level of granularity that we did in the report. But we will try to give you a good flavor for what our findings were, and make you familiar with what we discovered and what we're recommending. I know the Oversight Committee knows who we are, but I know there's members of the public who may not. So my name is Scott Berger, and I have a single person consultancy in process safety. I'm a chemical engineer with a bachelor's and master's degree from MIT and about 45 years of total experience. From 2001 to 2015, I served as the executive director for the Center for Chemical Process Safety, which is the umbrella organization for process safety efforts run by companies around the world. And we publish guidelines and provide training. So a lot of the approach that we took today in this project are based on documents and guidelines that are published by that Center for Chemical Process Safety, or CCPS. I've been working for eight years now as an independent consultant. I'm certified by CCPS as a process safety professional and been recognized as a fellow both of the CCPS and of the American Institute of Chemical Engineers. My colleague, Tim Maloney, has been my partner in this project. He has his own consultancy. He's the founder of a company called Petrocor, more than 35 years of experience, largely in the refinery sector. Tim actually operated catalytic cracking units, and so was invaluable to this project in understanding the way the unit is supposed to work and what actually happened. Tim was also the process safety lead for a major refining company, and among his duties performed many incident investigations in refineries, including of catalytic cracking units. What we are going to talk about today, of course, is the spent catalyst dust release incident that occurred on November 24th, 2022, and extended into the early morning of November 25th. We went over the physical evidence of the release, and that was the physical evidence wasn't recognized in the refinery, but was experienced outside the refinery and was reported to them by community members who saw the collection of white dust on various surfaces spread around the community. So the Contra Costa County contracted with me and my company to perform this independent root cause investigation. We identified 8 root causes in our investigation that broadly cover the way that PBF assessed the risk of catalyst release, the way they prepared their procedures and followed them, the way they trained the personnel that are operating the catalytic cracking unit, the way they empowered their employees to stop or pause work in unsafe situations or when things weren't going as they expected them to, and also in the way that they managed worker fatigue. So we'll get into that in just a bit. We'll talk about our objectives for the investigation and our approach. We'll present a brief overview of catalytic cracking and how that is supposed to work. Then we'll talk about how the incident evolved, the steps leading up to it, and what happened during the incident. We'll discuss our root causes and our recommendations to address them. We were asked by the Oversight Committee to also look into the subject of the use of wet gas scrubbers compared to electrostatic precipitators. The PBF refinery uses electrostatic precipitators, as do many refineries. And the question was whether if they had been using a wet gas scrubber, if that would have made a difference. And we'll talk about that. And then we'll evaluate the investigation report that the refinery prepared as part of the major chemical accident investigation that they're required to do by the county. So we'll get into all those topics and then, of course, be available to take your questions. So our objectives were to identify the root causes of this incident. And when we talk about root causes, we specifically are talking about gaps in process safety management systems. And by process safety management systems, we're talking about policies, procedures, standards that the company has, and the way that they are managed by the company. All right. So if we know that if we can correct gaps in these root cause, in these management systems that are identified as root causes, we can not only prevent this incident from happening again, but also prevent other incidents that might happen based on the same kinds of failures. So it's a very highly leveraged approach that we're taking here. We also evaluate some contributing causes, and we have recommendations related to those as well. So we have the recommendations for the root causes and the contributing causes. The way we went about doing this investigation was, first of all, to review a long list of documents that we requested from the refinery and that they provided to us, as well as data for the process that we went over in detail. We interviewed key personnel, and I do want to acknowledge all the personnel at PBF that we talked to, because we really feel that they provided very good, freely offered input that was useful for us in conducting this investigation. And overall, we followed the investigation approach that was published by the CCPS, by the Center for Chemical Process Safety. So now let me turn to the catalytic cracking and how, in general, this works. And we focus here on this slide on 4 major units in the refinery. And of course, in the PBF refinery, as in most refineries, there are a lot more units in the overall catalytic cracking process than that we're showing here. We simplified it and also taking out the pieces of equipment that aren't relevant to the incident, just to make it easier to understand. And we start in the center of the slide here with a reactor, and this is where the cracking takes place. There's also a stripper, and we'll talk about its function in just a bit. A regenerator that takes the catalyst and makes it ready for reuse. And also over on the left-hand side, the main fractionator. This is a distillation column that receives the product from the reactor and transfers that product to other columns for additional processing. Now, the main action for catalytic cracking occurs in the reactor, as I mentioned. We basically have a heavy hydrocarbon feed that goes into the reactor along with catalyst. They're introduced at the bottom of the reactor, and they flow upward through the reactor as the reaction takes place. The cracked gases come off the top of the reactor and pass over to the main fractionator, where that additional separation is done. The lighter components that come from the main fractionator will then pass to a tank known as the overhead accumulator. From that overhead accumulator, the product is isolated and taken on for additional processing in other columns. In addition, the overhead accumulator discharges to a device known as the wet gas compressor. And this serves as a pressure controller, essentially, for the main fractionator and for the reactor. And that's its primary function there. So from the reactor, the catalyst now will pass over into the stripper. That's the next vessel over to the right. And in the stripper, any residual hydrocarbon is removed from the catalyst using steam. And so that steam and hydrocarbon leaves the stripper and joins the stream flowing over to the main fractionator. And then the catalyst accumulates in the stripper. Now, from the stripper, the catalyst will flow through a device known as the stripper slide valve into the regenerator. And it's that slide valve that is going to control the flow of catalyst that goes from the stripper into the regenerator. Now, in the regenerator, the catalyst is arriving there with some coke, basically material that is starting to foul the catalyst. And the purpose of the regenerator is to remove that coke, essentially by burning it off, by contacting the catalyst with hot compressed air. And so the air is flowing upward through the regenerator as the catalyst is flowing downward. And as that air passes through the catalyst, it's going to entrain some fine catalyst particles. These fine catalyst particles are removed first by passing through these first and second stage separators, which you can see at the top of the regenerator. And the catalyst particles are removed by those cyclones, and the particles drop down through these blue legs down into the catalyst bed and get recycled. And the hot air leaves the top of the regenerator and goes on for additional processing. There is a pressure control valve for the regenerator that is on the discharge side of the regenerator. And also the air passes through a third stage separator and a fourth stage separator before to remove additional catalyst before the air The hot air then passes on to the carbon monoxide boilers, and then to the electrostatic precipitators, and ultimately discharged from the stack. So with a combination of the first and second stage cyclone, the third and fourth stage separators, and the electrostatic precipitator, the air that gets discharged under normal conditions should have an acceptably low opacity, and be an acceptable release to the environment. Now, the fourth stage separator is unlike the cyclones that we see in the regenerator. Instead of draining continuously and automatically, it has to be drained manually. And this is done under normal circumstances every few hours. As it fills up, it reaches an alarm point and then is dropped out manually. And that's done on a regular basis. And that, in general, is how the system works. Now, I have to mention a couple other things here. First of all, there is a safety device in the CCU, and that is a flare system. And if the pressure is too high or becomes too high in the reactor, the flare system can be opened, and there would then be a flaring event to relieve the pressure in the reactor and prevent an overpressure type of situation. Okay, so that explains how it's supposed to work. Let's now talk about the lead up in the events that led to the release of catalyst. And it started back on November 21st, 2022, when the flow controller on the air to the regenerator basically failed. And so when that failed, the airflow to the regenerator stopped, and this prevented the regenerator from being fluidized. And with that situation, the CCU could no longer operate. So when that happened, there were two interlock type actions that occurred. The first, this is the loss of the air, and then automatically the feed was diverted from the reactor. So basically the cracking catalytic cracker was being shut down. The feed was being diverted over to the main fractionator. Additionally, as a safety measure, the electrostatic precipitators were de-energized. And this is an important safety feature that I'll talk about in just a minute. There's one more thing I do want to mention, though. As part of restarting the catalytic cracking unit after a shutdown, one of the things that we need to do, and look over here on the left-hand side of the screen, you see propane going into the overhead accumulator. And this propane is important for the restart of the unit, because normally when the catalytic cracking unit is being started up, it's being started with air and steam. And the wet gas compressor requires a gas of a higher molecular weight than you can get from either air or steam. And so it's important to bring in propane from the refinery storage in order to allow that wet gas compressor to work. And we'll talk about that propane and its significance in just a little bit. Now let's talk about the electrostatic precipitators and why they're de-energized. And this largely started following a significant explosion that occurred at the ExxonMobil Torrance, California plant back in 2015. Their CCU had shut down, and during the shutdown process, some hydrocarbon was able to leak through into the catalytic cracker. Leak into the electrostatic precipitator. And you have to understand that with electrostatic precipitators, it's basically working on the principle of using electric sparks to remove particles. And so electric sparks and hydrocarbon vapor, getting those two together essentially means you're going to have an explosion. And that's in fact what did happen. And the industry got together and realized that there were many scenarios within catalytic cracking units where if there was a shutdown catalytic cracking unit or one that was in a restarting mode, it would be possible for this kind of explosion to occur. And so the refining industry as a whole agreed that it was an important safety measure to de-energize electrostatic precipitators, basically from the time that the CCU shuts down until the time it reaches stable full operation, in order to prevent this type of accident to happening in the future. Now, of course, when the electrostatic precipitator turns off, that's one of the pollution control measures that the refinery is relying on to remove catalyst particles from the emissions. And so that did really, in this particular case, and generally, when this happens, there will be a high opacity type of event coming from the stack. However, the opacity event is not what we're investigating. We were investigating the significant release of catalyst that happened after that. Now, on the 21st, it turns out that the refinery did have the spare part for the failed controller, and so repairs began immediately. One of the things that was very important that occurred at this time was that there was a key employee who we'll refer to as A, who was a very dedicated employee, very highly knowledgeable, highly skilled, very dedicated to the refinery and to its success. And this person began a series of multiple days working 20 plus hours. And this person would work for that 20 plus hours, go home for a short rest period, and then come back and work an additional 20 plus work hours. And this went on for basically until the CCU was back restarted. So this term will turn out to be an important part of the incident. On the 22nd of November, the component was repaired and efforts to restart the CCU began. As that began, there were difficulties in lighting that compressed air preheater, and this went on for quite some time trying to get that lit. But finally, the refinery did have get the preheater lit, and then the startup activities could then proceed. And the first step of this is to bring the CCU into a condition known as hot catalyst recycle. So there's no feed going in, but the catalyst is being fluidized. It's with steam and with air and circulating from the regenerator to the reactor, to the stripper, back to the regenerator, and getting that stabilized as part of the first step. And that hot catalyst circulation was realized, and by the morning of November 24th, that was Thanksgiving morning. So this has taken us up now to just about noon on the 24th of November. Now, right before the feed reintroduction began, which happened right after noon on the 24th, the engineer told the operators on the day shift that they should not reintroduce feed to the reactor unless the stripper slide valve was operating in automatic mode. And the procedure for restarting the CCU did require that stripper slide valve to be in automatic. It happened to be in manual when the engineer made this request, gave this instruction. But anyway, that was part of the procedure and part of the instructions. The engineer further said that if the stripper slide valve could not be run in automatic, that the operator should call in an instrument tech to resolve that issue. So that communication was made. Also, right before the feed was reintroduced, in one of the other columns that are not shown on this diagram, basically all the way off to the left of the screen, on the side away from the screen, had a pressure excursion, which led to the first flaring event of the day. So there was a flaring event from the CCU, but not from the CCU unit as a whole, but not from the reactor itself. And this occurred right before noon on the 24th. Now, right after noon, the operators then began to introduce feed to the reactor, and this was done as normal, little by little, by very slowly increasing the flow rate in increments through A, as you can see on the diagram, while shutting or very slowly closing the flow through B, that's bypassing over to the main fractionator. Now, when this happened, unfortunately, the stripper slide valve was still in manual. It was not in automatic. Now, with that initial introduction of feed, the pressure rose. It rose in the reactor, and when that happened, the operators decided to flare that pressure through the flare system, and so that became a second flaring event from the overall broader CCU complex within a very short period of time. Around that same time, the CCU operators received a communication from refinery logistics saying that the inventory of propane in the refinery was starting to get low enough to where it was approaching a minimum inventory level. Now, it wasn't a level that was critical that was going to prevent the startup of the CCU, but it was a communication that needed to be made according to refinery policy, and the communication did come in. This key employee A instructed the colleagues that there should be no more flaring that day during the startup, and additionally that even if some additional propane might be convenient to have, that the personnel should not draw any additional propane beyond what they were taking at that moment. Okay, so the startup continued, the introduction of feed continued through the afternoon and on into the evening shift. And again, the stripper slide valve remained in manual control over that period of time. Now, the incident actually began a little bit after 8:30 in the evening. And again, as the valve A was being gradually open and valve B gradually closed, there was another pressure excursion in the reactor. Okay, and so that basically the reaction from the additional feed going in raised the pressure in the reactor, and now without flaring, that pressure was pushing harder on the catalyst that was in the stripper, forcing it over into the regenerator. And operators were taking action to both try to increase the pressure in the regenerator to reduce that differential pressure, and also to close down manually on the stripper slide valve to control the flow of catalyst. But it turns out that the stripper slide valve was not closed fast enough in that manual operation mode. And so what happened was that the regenerator catalyst level went quite high. And when that happened, the first and second stage cyclones became choked. And so catalyst then began to flow into the third stage separator. And they filled the fourth stage separator. And now with the fourth stage separator filled, essentially all four of those separators were not removing catalyst. And so the catalyst then passed on through the carbon monoxide boilers, through the deactivated electrostatic precipitators, and out the stack. And so this was the beginning of the catalyst release. Now, while this was happening, the personnel did not recognize that there was a release that was occurring. First of all, they didn't associate the fact that the fourth stage separator was at high level with a condition that would be leading toward a significant catalyst release. Also, they couldn't rely on the opacity meter on the stack because with the electrostatic precipitator turned off, that stack opacity meter was already reading the maximum opacity level. And so since it was already reading maximum, it couldn't read any higher than that. In addition, there was a slight breeze blowing that night. It was 3 to 6 miles an hour or so. And it was blowing the catalyst away from the refinery. And so there was no catalyst observed falling inside the refinery. And really the first indication that the refinery had that there was a catalyst release, well, first they realized that there was a release was when they got calls from the community after daylight on November 25th. So here's a little bit more granular of a timeline. So as we mentioned, the operators were continuing to increase the feed rate from noon on the 24th, and that continued on until just after 6 o'clock in the morning of the 25th. That the stripper slide valve remained in manual. It was supposed to have been an automatic, of course, when the feed was started back at noon, but it remained in manual until 11:30 at night. And by the evidence that we reviewed suggests that as soon as the stripper slide valve was put into automatic, the period of the highest rate of catalyst release ended. We believe that the vast majority of the catalyst that was released in this incident was released before 11:30, and that the bulk of that release ended at 11:30. But it didn't completely end because that four-stage separator was still full. And so as long as the operators in the plant were continually draining catalyst from the four-stage separator, so as long as that separator was at its high level, it essentially meant that there were that the other separators were not functioning at their full capacity. And so because of that, we believe then that the major catalyst release was continuing up until 4:30 in the morning, when the operators were finally able to establish an empty four-stage separator. However, we believe that probably 80% or more of the catalyst was released before 11:30. Now, after the four-stage separator was fully drained, indicating that all of the separators were now functioning properly, we returned to the situation where there was just high opacity. The actual incident ended, even though the opacity continued, and that did continue until the CCU reached full operation just after 6 o'clock in the morning, and the electrostatic precipitators were brought back online at 6:15. And that essentially ended the incident overall. Now, one of the things that we do in terms of obtaining the root causes of an incident is to look at what we call a causal tree. And for those of you who have seen the report that we prepared, it's a pretty detailed tree, and just for purposes of this presentation, we wanted to have something that was a little bit more streamlined, that is easier to follow for all the participants. So this is not the same causal tree, but you'll see the parallels to the one that's in our report. So we start with basically the major deviation that occurs, which was the high level in the regenerator that led to the catalyst release. And we were asking the question, so why did this happen? And we keep asking the question, why, until we find management system gaps. And that's when we know that we've reached our root causes. So why was there high level? Well, there was two reasons. One was that there were inadequate safeguards guarding against high level in the regenerator. And the second was that there was an excessive or high catalyst flow rate from the stripper to the regenerator. So now we're going to ask why did these conditions occur? Well, when we talk about inadequate safeguards, it turns out this scenario was identified by the previous owner Shell and also by PBF in process hazard analysis that they carried out. But in doing so, the analysts didn't recognize the severity of a catalyst release. So they believed it would be simply an opacity event. They didn't realize it would be a major catalyst release. And we asked, well, why was there a high catalyst flow rate from the stripper to the regenerator? And again, there were two reasons for this. The first was that stripper slide valve was in manual when it was supposed to have been an automatic. And the second is that the operator response to that high flow rate wasn't fast enough. Okay, so this takes us, now we start to get into our root cause discussion, and we'll look first at this operator response. And our analysis essentially discounts operator error as a root cause. And the reason for this is because humans make mistakes. And what we really need to do is design our processes and design our management systems and safeguards so that an operator error doesn't lead to an incident. And so we explicitly do not find operator error as a cause here. Now let's look at the process hazard analysis. And the reason that this scenario was identified at a lower consequence than turned out to be realized had to do with guidance that was provided in the standard and policy that Shell and then PBF provided to their analysts. So this is our first root cause: inadequate process hazard analysis guidance regarding catalyst release. So then let's focus on why that stripper slide valve was in manual. And there's really two reasons for this. The first was that even though the procedure specified that the slide valve should be in automatic, the procedure was not followed. The second is that it was fatigue, and we believe that the fatigue of that worker A played a role in why the procedure was not followed and why the decision was made to put that stripper slide valve in manual. When it comes to the procedure, we have a much deeper analysis, and there are 6 individual root causes that are tied to the procedure not being followed. And we'll talk about those on our next slide. But as far as fatigue, the refinery does have a policy for managing worker fatigue, but we identified a number of gaps in the fatigue management system of the refinery. So that's we have root cause 1 and 8, and now let's talk about 2 through 7. Okay, so the first relates specifically to the refinery policy for procedures, And we found that there was a practice in the refinery of deviating procedures without properly managing the changes that are made in the field. And we recognize that in all operations, not just refineries, but chemical plants and other kinds of facilities, there are times when there are upsets that operators have to take manual control back, and this generally has to be done in a way that's well organized and well analyzed. And we found that the process that the refinery used when deviating for procedures was not as formal as it should be. Secondly, in procedures, one of the key features in a procedure is that there should be appropriate cautionary statements. So when, for example, in the case of there was an important reason why the stripper slide valve needed to be an automatic, but that reason was not given in the procedure. And when you give the operators the reason, it gives them basically more information upon which to do the analysis that we talked about in the previous root cause. So basically the procedure management system failed to ensure that there was appropriate cautionary statements. In the case of stop work authority, again, the refinery does have a very comprehensive stop work authority policy and program. However, it does not drive workers to pause to reevaluate work when things are not going exactly as they plan. So it does talk about when operators recognize a dangerous situation, and that is a good thing. But when things are not going the way you expect, that's a good time to stop, to pause, to say, why isn't it going this way? And let's figure it out before we go any further. There was a related cause related to training. The reintroduction of feed process, or procedure rather, is one that is not performed very routinely at the refinery. And to the best of our knowledge, the previous time feed had been reintroduced to the CCU was well over a year earlier. And one of the policies related to the CCU is that when performing infrequently used procedures, there is supposed to be just-in-time training prior to executing the procedure to remind the operators of critical features of that procedure. And we found that this wasn't done. Also related to training, we found that the operator training did not provide the operators with enough information to know that a high level in the 4-stage separator is probably an indication that there very well may be a catalyst release. So that was not in the training, and so that was another gap. And a third training related finding or root cause was that the training didn't adequately address instrument failure mode. So in other words, the failure mode related to the stripper slide valve, why it needed to be in automatic and not in manual, how to troubleshoot these problems, and when it's important to call an instrument technician. Now, it's also common in root cause analysis to identify contributing factors. Now, these are things that you can't establish a direct causal link. However, if these factors things had gone differently, it might have given the operators a better chance to have prevented the incident. And we identified two different contributing factors. And the first were a series of distractions that occupied operators' attention, which potentially either distracted them or slowed or delayed the manual adjustments that were being made to the stripper slide valve. And an example of these was that directive to not flare and the directive not to draw additional propane. And there were some other operational issues with the with the CCU that were additional distractions. Again, none of those caused the incident to occur, but they were more things that the operators had to pay attention to, and so it was they were distractions. We also found that there were some engineering designs that were not present in the PBF catalytic cracking unit, but are common in other refineries' catalytic cracking units. Had they been present, they might have helped the operators avoid the incident. And one is advanced control of the differential pressure between the reactor and the regenerator. Now, in the PBF plant, the regenerator pressure is controlled directly by the operator, but we found that was being done properly. However, if this had been done in automatic, that would have relieved some of the burden from the operator and made the response easier. And additionally, it turns out that there was no direct measurement of the feed that was flowing into the reactor. There was an overall measurement of feed that was the combined flow into the reactor and the flow that was bypassing to the primary separator, but there was no direct measurement of the flow. And had that been present, it would have been easier to control in the gradual reintroduction of feed. Now, we brought up that we were asked to talk about the topic of wet gas scrubbers versus electrostatic precipitators, because there was some speculation that had the PBF been using a wet gas scrubber instead of an electrostatic precipitator, that this incident could have been prevented. And there are some pros and cons of wet gas separators compared to electrostatic precipitators, which we wanted to highlight here. So first of all, on the positive side, it's not necessary to shut down a wet gas scrubber in the case of a shutdown of the CCU. There's no electrostatic sparks involved in that process, and so if there had been a wet gas scrubber, the opacity situation had existed before the incident, would have been prevented. So that's one positive. And also, the wet gas scrubber would have been operating at least for the earlier phases of the release in the evening of November 24th, and it would have probably prevented at least some of the release. And we'll talk about why it's not all of the release, but it might have reduced at least some of the release. Now here we get that, and that takes us to the cons of wet gas scrubbers. So you can imagine, or think about it this way. Typically, the electrostatic precipitator, they're asked to remove a few pounds of catalyst fines per hour. That's under its normal situation. And if we had a wet gas scrubber instead of electrostatic precipitator, that would have been its job, to remove a few pounds of catalyst. But in this event, what was happening is it would have been receiving multiple tons of catalyst per hour. And one of the key things that we have to keep in mind when you're using water to remove solids from an airstream is that once the solids are into the water, the solids then have to be removed from the water before the water can be recycled. And with several tons an hour of catalyst basically flowing into the solids removal equipment, it's highly probable that the solids removal equipment would have been overwhelmed and clogged up, which would ultimately have led to the shutdown of the wet gas scrubber. And so we would have seen the wet gas scrubber remove a few maybe a few tons of the release, but the vast majority of the release would have continued and as was experienced. And so for that reason, I guess we should also mention that, and this is not really related to the incident, but a wet gas scrubber uses water to essentially contact with very hot air. And so what that's going to do is evaporate water. And so that makes a wet gas scrubber a large consumer of water. And in some parts of the world that's not a problem. But I know in the Bay Area, sometimes you do run into water shortages. And so that might have been a drawback of using a wet gas scrubber. But in balance, what we conclude was that while a wet gas scrubber would probably have prevented the high opacity condition before the incident, and it may have reduced somewhat this overall severity of the incident, the majority of the incident would still have occurred, and therefore using an electrostatic precipitator instead of a wet gas scrubber is neither a root cause nor a contributing factor in this incident. Okay, so now let's get to our recommendations. So related to that first root cause of inadequate process hazard analysis, we recommend that PBF clarify their corporate guidance regarding environmental catalyst releases. And when we think about root causes, we try to prevent other incidents that might be related to that same root cause, that same management system failure. So we also recommend that they review other potential scenarios where there might be environmental releases where the environmental consequences were underestimated. Our second root cause had to do with deviating procedures without managing field changes. And so again, we make another recommendation to close that gap, but to review and revise those site procedures for managing field changes to make that a more robust type of process. So promptly review the changes, have an appropriate level of approval to the changes, involve the appropriate personnel in the changes, and then provide metrics so that the refinery management can provide oversight and make sure that this program is operating the way it's supposed to be. In terms of cautionary statements, we made a recommendation that in the policy or the system for developing procedures, that PBF revise their checklist for things that should be included in procedure to ensure that cautionary statements are included when appropriate. So again, this would be not just putting in a cautionary statement related to putting the stripper slide valve in automatic, but any other situation where appropriate cautionary statements should be provided. And specifically to update the procedure for that was being executed at this time, that CCU 1110, to include a cautionary statement explaining why that stripper slide valve should be an automatic before reintroducing feed to the reactor. In terms of the stop work authority, or maybe in this case we should say pause work authority, we recommend that the stop work policy or program and the associated training with that to include evaluation of complex situations where they're in any kind of non-routine work, and also to provide additional consideration of situational factors in the pre-startup safety review. So where it's known that startup has to be done and where situations aren't exactly the way are expected, that to make sure that that evaluation is being done before rushing into startup. In terms of providing just-in-time training, we recommend that the training management system be updated to ensure that the just-in-time training, especially for this procedure, but other relevant procedures as well be conducted, and put that also into the training workbook for the console operators of catalytic cracking unit, for the catalytic cracker console operators. We also identify the operator training not addressing the rationale for alarms that signal the potential catalyst release. And we also recommended that PBF develop or update criteria for operator training and conduct reviews of training manuals to make sure the basis for all alarms that are used as safeguards are included in those training materials. We found that the operator training did not address instrument failure modes, including the troubleshooting and when to call instrument technicians. So we recommended that PBF standardize their approach to malfunctioning instrumentation, educate affected personnel. Instead of trying to have workarounds, basically let's fix the problem, instrumentation problem that exists. Address the failure modes of the instruments. When should instrument technicians be called? And what are the appropriate procedures in the refinery for bypassing safety devices? And lastly, the gaps in the fatigue management system. The refinery does have a fatigue management policy. We recommend that it be modified to explicitly include oversight of the fatigue of both hourly and salaried employees that are performing safety sensitive activities. There are some individuals who, if that were done, would not have been covered previously. So those individuals should be educated on the changes. And lastly, that there should be a mechanism provided so that refinery leadership are providing more direct oversight of the fatigue policy, supported by metrics, so they can understand, is there a trend toward greater worker fatigue, or is the fatigue policy being followed, and so on. We had a couple of recommendations related to our contributing causes. First was the management of the differential pressure between the reactor and the regenerator. We recommend that the refinery consider upgrading the control scheme of that differential pressure to what's known as cascade control mode, so that the regenerator pressure would be set based on the pressure in the reactor. For the second contributing cause, the lack of flow indication, we recommend that a flow meter be added to measure the direct flow into the reactor during this reintroduction of feed process. So that completes our root cause analysis. We were also asked to evaluate the major chemical accident incident investigation report that was submitted by PBF to the Oversight Committee. The PBF identified a total of 5 sort of combined root causes and contributing factors. The first one that was identified by PBF was inadequate manual adjustment of the regenerator pressure control valve. And we just talked about that in our recommendations as well. We found that was a contributing factor. It wasn't a root cause, but certainly deserves some attention. Root cause number 2 was inadequate manual adjustment of the stripper slide valve. And so what we find that what this root cause does is put the blame on the operator, and which we don't believe is appropriate. So what we instead identified were 6 root causes related to, and you saw them: procedures, stop work authority, and training. PBF identified a contributing factor, which was the curtailment of propane to the wet gas compressor. Our analysis showed that there was adequate propane to start up the CCU, and in fact, by the time the incident occurred, there wasn't much propane that was even required. But it was a distraction to the operators, and as such does factor into the contributing factors that we identified. PBF identified 2 human factors, which I think at least one of them is probably more like a root cause, and one is more like a contributing factor. The first one had to do with a deviation from the fatigue policy, and essentially the way this was written was that the operator or the individual, this is worker A, made the decision on their own to deviate from the policy. And again, we find that blaming the worker is not the appropriate action. Instead, our recommendation focuses on the way that refinery leadership should manage their fatigue management program and the program itself, and needed to be upgraded. And the second human factor that was identified by PBF was not completing end of shift reports reliably. And we did confirm this in our investigation. However, we didn't establish a causal link to this factor, to the end of shift reports. And so we do think it's important that end of shift reports be completed, but it didn't factor into our investigation. So now let's talk about the corrective measures that PBF had proposed, and they proposed 11 in total. And I would say that for the most part, these recommendations go largely in the same directions that we had recommended, but in a lot of cases, not as far as we recommended. The first one was to develop a control strategy to automate that regenerator and reactor to regenerator differential pressure. And that strategy has been developed by the refinery. This actually was proposed to be implemented in 2018 by Shell during the 2018 turnaround, but it wasn't done. It's now scheduled, or planned at least, for the 2025 turnaround. And as we mentioned, we found that to be a contributing factor, and we do support this corrective action. The second was to provide additional alarm guidance for the scenario, and that is complete. Again, that was compatible with our recommendations. Ours did go a little bit more broadly in that we want to make sure that these kinds of alarm or warning statements are more reliably included, and not just for this particular alarm. The 3 was to provide additional operator training on maintaining the reactor and regenerator differential pressure and catalyst bed level, and PBF has completed that. And as of November, the last time we had checked in, that was well underway. It may be completed by now. Our recommendations went broader than that, related to the training management system in terms of just-in-time training, and the importance of following procedures the way they're written, and to follow a procedure modification program with appropriate oversight. PBF corrective measure was to modify the procedure CCU 1110 to provide additional instructions about when to put the stripper slide in manual, and that is complete. And again, that is also consistent with the recommendations that we made about cautionary statements. But again, we went broader to make sure that cautionary statements are placed wherever they're appropriate. PBF recommended, or has as a corrective action, to evaluate operations to increase the molecular weight of the gas to the wet gas compressor during feed reintroduction. And this would give them more flexibility. If they start to run out of propane, they could use other materials such as butane. And they did develop an option to use butane, which is now in the engineering stage. And as we mentioned, the availability of propane, we didn't believe was a factor. It was a distraction. Nonetheless, we do support this recommendation in terms of giving the refinery additional flexibility. Number 6 was to reiterate to personnel the expectations and requirements for the refinery fatigue policy, and that was done. As we said, our recommendation went deeper in terms of improving the way that they monitor and enforce the fatigue management policy. The 7th was to reiterate to personnel the expectations and requirements to complete end of shift report, and that is also complete. As I mentioned, that was not found by us to be a root cause or contributing factor, but it certainly is an important thing to happen. Number 8 was to provide additional tools to increase the effectiveness of staff work schedules and fatigue management, and that is also complete. Our comments for this one are the same as for number 6. I think one of the things that we noticed was that the refinery was putting a lot of the onus onto the shift supervisors and to the workers themselves. And what we really want to happen is to have appropriate leadership oversight over the fatigue policy, because that may involve assignment of personnel. It may involve hiring of personnel or additional training in terms of solutions. So it really needs to be overseen at the leadership level. The 9th corrective action from PVF was to add indication of the 4-stage separator differential pressure, that high level indicator, to the Utilities Council with appropriate alarm and response guidance. And this too is complete. I think this is very similar to the recommendation for our root cause number 6. Again, an important thing to do in terms of detecting and recognizing that there has been an incident relating to catalyst release. Number 10 was to update the community monitoring procedure to include activation and response for defined opacity events. And again, PVF has completed this. This is also similar to the recommendation we made for our root cause number 6. And lastly, determine if the electrostatic precipitators can be safely activated during the CCU startup process. And the refinery indicated that they have completed that work and deferred to industry guidance, which continue to advocate against activating electrostatic precipitators during this phase of operation. And we do agree with this industry guidance. Also, it was not a root cause, as we demonstrated. Even with an electrostatic precipitator designed to handle pounds an hour, being asked to deal with tons an hour, it really could not have done much to reduce the consequences of the incident. I think that takes us through the majority of our report, at least the part that we wanted to report. I know Nicole wants to go over next steps, and then we'll be ready to take some questions.
Great. Thank you very much for that presentation, Scott. So yes, I wanted to quickly go over the next steps from today's meeting. So today's meeting, we have had Scott present out a draft report of this incident investigation root cause analysis to the Oversight Committee. The Oversight Committee has also received a copy of the draft report and has had the opportunity to provide comments. I will be working to collate all of those comments and send them over to Scott so that Scott can prepare a second draft report, which is the report that will be used for our 45-day public comment period with public meeting. We are looking at opening that public comment and public notice period at the end of February, which would last for 45 days. So that would take us through about mid-April, and we are targeting having a public meeting in March. After we go through that 45-day public comment period meeting, we will respond to all public comments from both the public meeting that will be hosted, as well as any comments that come into our office via written comments or emailed comments. Just as we are doing with the Oversight Committee's comments, those comments will be collated, and we will work with Scott to address all public comments and make any amendments to the incident investigation report as needed from those comments. And then the last step would be presentation to the Board of Supervisors and City Council. Yeah, and I will be dropping the website where we post all of our information related to PBF, including the recordings of these Oversight Committee meetings, agendas and minutes, and additional information as needed. We also have a sign up for a constant contact list so that you can be apprised of the work that we are doing with PBF. So if you've not already joined and you want to join, that website will also take you to that link as well. So thank you, Scott. I'll turn it back over to you. I don't know if you had an additional slides.
No, that's it.
Okay, great. So now we will open it up to our question and comment period from our Oversight Committee members. So Oversight Committee members, if you would like to ask a question or provide a comment, please raise your hand. And I see that Tom has raised his hand, so go ahead, Tom.
Yeah, Scott, thank you so much for the presentation. It was very interesting and informative. So the question that I have, it's really a general observation that leads to a few questions. And thinking of the stripper slide valve, which is a very, very important part of this whole process, right?
Yes.
It just sort of boggles my mind that there isn't a big blinking red light that says, hey, this is either open or closed. And if or open or closed, or rather on automatic or manual. And if that is the case, and it is so important, why isn't that status interlocked with the settings on these feed valves that are feeding gas into the reactor? And the other thing that kind of surprised me is the idea of, well, hey, maybe we better have a differential pressure sensor between the reactor and the the other containment units. And I just don't understand why that whole plant would not be absolutely full of sensors with the appropriate interlocks. And so that just gets to this fundamental idea that, why is this plant so reliant on humans who are following a detailed set of procedures without really that being augmented by a set of automated controls? Does this reflect a systematic underinvestment by PBF in the plant? Because you would think that a plant with such a high potential environmental impact would have a design where there would be a fundamentally automated control system that human operators would have to consciously override, in order to do things that sort of fell outside the normal range. And so this lack of kind of an automated framework and a modern system of sensors and interlocks makes me think that it leads to this idea that, as you pointed out in your report, that the operation of the plant sort of relies on these sort of super workers, and there's a tendency of the staff to deviate from procedures, things like that. And does that represent kind of an underlying sort of lack of faith in the operational integrity of the plant? And so I guess what in the end, I'm wondering, these recommendations are all about sort of procedures and processes on how to properly operate a manually controlled plant, when in reality, there's a fundamental problem that things that should be automatically sensed and controlled and interlocked aren't done that way. So I'm sorry if this has been more of a rant than a a specific question, but that's my general impression.
Yeah, thank you, Tom. When we talked about automating the pressure control based on differential pressure, I think that is probably speaking to a lot of what you were talking about. I see that Ken Axe has his hand raised, and I'm sure he'll answer this question as well. But as far as whether there should be an interlock or not, my guess is that would probably be undesirable under normal circumstances, because I'll probably better to let Ken answer that question. But we do feel that there was a tendency, and I think what we used in our report was an attitude essentially, or a policy that says operators are well trained to be able to take manual control in order to achieve an objective that are set for them. And we we believe that's a little bit too broad in terms of asking workers to control things in a manual environment. Personally, I have operated plants myself. Tim has operated plants, including CCUs himself, and there are occasions, time to time, where an instrument gives a funny reading, the computer makes a funny calculation, and it's important for the operator to have the knowledge to be able to take manual control, put the process back into a steady state operation, and then reestablish the automatic control. And what we found was that the refinery was giving much more latitude to their operators than that, and I think that was part of the issue.
All right, thank you, Scott. If you have no further response to Tom, or if Tim does not, then I will move on to our next Oversight Committee members. So we'll go with Ken next, and then Ben. So Ken?
Okay, thank you. So I'll go through the comments that we had on the report, and some of them are brought up again in the presentation too, so we'll cover both. So the first comment, so in the report, it is mentioned in 5 locations. So once on page 6, 3 on page 12, and again on page 14, it also made the presentation. So this is regarding the engineer having given direction to operations to keep the stripper slide valve in automatic, or to not operate it in manual, and to inform the instrument techs if they had problems with it. So during the on-site interview portion of the root cause analysis, we don't remember operations alleging that occurred, that communication was made from the engineers. I've since spoken to the day engineer, the night engineer, and for good measure, their manager. All 3 of them are very clear that they did not give that direction, and frankly, that would be really exceptional. So operations doesn't generally take direction from the engineer, so they would approve the technical operation of the plant, but they would not make such direction, and are very clear that they did not. That was also a comment. As I mentioned, it shows up in 5 places in the report. It did not show up in draft 1, so that was not something that we then subsequently had an opportunity to discuss with Scott and Mike Dossie after the issuance of draft 1, before the issue of draft 1.1 and 1.2. 1.2 is the version that we all received.
Ken, can I just take a quick pause? I'm very sorry to interrupt you, but I want to provide some clarification on this. So for those who had not been part of some prior oversight committee meetings or were not aware, there was an earlier draft version that was distributed to the oversight committee. However, upon the oversight committee review, of which Contra Costa Health is a part of, Contra Costa Health had some additional technical questions and items that we wanted to clarify. So Contra Costa Health went on site to PBF with Scott Berger to evaluate the questions that we had and ensure that there was that was addressed. And we also felt that at that point in time, the report was highly technical, and we wanted to be able to provide something that was less technical for the oversight committee and eventually what will be the public report. So that is why Ken is referencing a version 1.1 and a version 1.2. And those activities were reported out at an oversight committee meeting for full transparency so that people were aware of our status. And so the report version 1.2 is the report that Scott developed after the on-site visit with Contra Costa Health, of which Michael Dossi was a participant, Scott Berger, and PBF. And so now what we're talking about is report 1.2, which was presented to the Oversight Committee, and also Scott's presentation. So I just wanted to provide that clarification. Thank you. I'm so sorry, Ken. Please go ahead with your comments.
No problem. Just kind of further to that, though, in addition to addressing those comments, there are a number of features that appear for the first time in revision 1.2 that were not in the prior draft of the report and were not discussed. So we have not discussed these yet with Scott, and would like an opportunity to do that still. So the second one
And
also,
this venue is your opportunity.
Okay, so do we want interaction with Scott at this point, or just go through them?
No, please go ahead and go through your comments in this oversight committee meeting. Scott might not address all of them, but I believe you've also provided them at this meeting, but you've provided them in written form, which they will be addressed. Okay.
So the second one, the issue on this one was also not, it did not appear in previous versions of the report, so we have not discussed it yet. There's a comment under culture of accepting deviation from procedures on page 12. There's a phrase in here. It was learned that the refinery broadly considers operations to be objective-based. We do not regard operations to be objective-based. We didn't indicate that we do. I think that was an inference made from a slide valve being placed in manual instead of automatic, but then training to operators to know why, when, and how to take control of a system if it's not responding as designed or anticipated. But we did not agree with that characterization that the refinery broadly considers operations to be objective-based. There was conversation during the on-site portion of the meeting. I think if you look at the notes, you'll find that the agreement with that proposition was between Scott and Tim, not with the refinery. Next one also did not appear in the earliest draft, and this goes to something both in the report on page 13 and also in the presentation. So this is regarding just-in-time training. In fact, so the statement that's made in the report is that there were no records to indicate that either the specialist or the shift supervisor received the just-in-time training for operating the CCU console. In fact, CCU 1110, CCU 3305, and CCU 3310 are all administered every 3 years. They're not subject to just-in-time training because their use is not predictable. So in the description of what is subject to just-in-time training, it's not just infrequent, but it's also routine. So things like startup, shutdown, startup after, turnaround, things like those that can be planned are trained just in time. Whereas things like going into hot standby without recirculation, going into hot standby with recirculation, and then reintroduction of feed are actually trained on every 3 years. And that's also just kind of a distinction. So the general application of startup and shutdown, and I think we even heard pre-startup safety review. In fact, during this incident, the unit was never shut down. The unit went to hot standby without recirculation. was subsequently moved to hot standby with recirculation, and then reintroduction of feed. So those are all separate procedures. There are distinct procedures for shutdown and for startup. None of those were applied here. Okay, next in the causal tree, there appears, and in the presentation as well, comment about the PHA, the application of the team. So just to clarify, what the PHA team does is based on known incident or consequence history. So, for example, things that have occurred at the plant, within the company, within industry, or anywhere in the world, we land those on the matrix. We don't start from the matrix to find consequences of deviations when doing a HAZOP. So prior to November 24, 2022, PHAs done that involved catalyst carryover through the COBS and ESP did not recognize, because we were unaware of the phenomenon of catalyst aggregation and fallout in the community. So what you see is the risk ranking, the environmental 2 ranking, commensurate with the known consequences of catalyst carryover historically, and that's how it's ranked. And with the environmental 2, you find that you have a sufficient number of independent protection layers, and the team doesn't recommend further independent protection layers. You'll also find, though, that in the PHA conducted since November 24th, 2022, the team does acknowledge this as a possibility and does, with an environmental 3 consequence instead of a 2, you find that you are lacking an independent protection layer, and that is the basis for some of the recommendations made both by us and by Scott and Tim. Let's see. All right, just a distinction on the comments on stop work authority. So stop work authority is a very specific requirement in CalARP and CalOSHA PSM. We have other intervention programs that I think would be more appropriate for addressing the opportunity for complexity of an operation to be addressed rather than in stop work authority. So that's just a minor technical point. Back on page 22, so I know we did have some discussion about this. The issue of alarm flooding did not come up in the presentation, but I think it still remains in the report. We did want to clarify that the numbers reported, so the numbers that that we issued were for the combination of alerts and alarms, and not all of which enunciate. And for the 2 time periods where there was a total count of 13 between 1950 and 2000 hours, and between 2000 and 2010, there were 12. The number of reds and yellows, the ones of higher concern, are 3 yellows, 0 reds from 1950 to 2000. 2 yellows, 4 reds from 2000 to 2010. So those are significantly under the alarm count of 10 per 10 minutes. And certainly, again, when you factor per operator and you had 3 operators on the board, the numbers would not be overload. They do show up on the listing, but the way they show up is in colors. So the white alerts are very easily distinguished from yellow highs and red urgents. In addition to that, the number of them, so that the running list has 25 lines on it. So both of these 10-minute periods combined, you'd actually have the first one not dropping off until after 20 minutes. So it was not a case where you had more alarms than the operators could handle. We do have written comments, and Scott, those will be passed along to you. And we're happy to answer those.
Thank you, Ken. Ken, I think that, in light of the fact that these comments are also written, and there were, you had various comments that, we were only able to hear verbally, we will make sure that those are all addressed as part of the Oversight Committee comment addressing period for this report. And I'm going to now call on Ben for his comments, unless Scott, you have an overall response, but I think at this point in time, it would, you do not have to address every comment individually. We will make sure that's done as part of our process.
I don't know, Tim, would you like to say anything about those comments?
Boy, there's a lot to talk about. Did you want me to start? Or is there anything specific, Scott, you want me to address now? Because I could go on for 20 or 30 minutes pretty easy.
I think if we don't have an overall comment, we will hold off on that and address each one in our written format, if you don't mind, Tim.
Yeah.
No, that's fine. That's fine. We'll wait.
All right.
And Ken,
thank you very much.
for your thoughtful comments. I appreciate that.
Okay. Great. So our next commenter is Ben, and then we have Nick.
Thank you. I have a couple comments. Start off about the slide valve. And then basically, was the unit shut down? Was it open? Was it inspected for damage? Was there some type of erosion or other type of like I said, damage? When? How often did that happen? And then just another issue I wanted to raise was, a lot of people understand that the Air District found that the wet gas scrubber was feasible in its own air quality rule analysis and decision. And a lot of people in the community want to know, we're pointing out the fact that replacing the ESPs with the wet scrubbing would eliminate a source of ignition that is an explosion hazard. And this was one of the issues in the incident. Does the report, talk about whether it would be inherently safer to have equipment solution or, does the company do any adequate inherent safety analysis? And did your report, talk about this feasibility?
Yeah, thanks,
then,
Ben.
Yeah.
Oh, okay. One more. Okay. All
Yeah,
right.
I think Nicole kind of got to this, the investigation can't just be, based on, interviews and documents. It needs to be people who took a look and actually looked at the slide valve in particular. And so we need to know, has that actually occurred? Have people actually looked at the equipment, et cetera? And, on the process hazard analysis, the PHA of Shell, it doesn't seem like MRC, really did a good job of identifying, the issues of that unit, and how is that going to get addressed? Will there be a safety analysis for that? And that's all I got.
Thank you, Ben. So I'm looking at the time. It is now 11:46. So again, I think we're going to make sure that we're going to address all of these comments as part of our written comment process, including comments from this meeting. So I'm going to move on to Nick and then Tony so that we can give our members of the public an opportunity to ask questions as well.
Thank you, Nicole. Yeah, I just wanted to read through my comments that I've submitted for the report, just to kind of get it on the record. But number one, did the regen pressure control valve have previous issues of being stuck? Were maintenance records or reports of issues looked into? Number two, the mixed message about flaring, again, from the report, not necessarily from this slideshow. I'm not sure I understand the safety aspect of flaring as described, combined with the public outcry against flaring, or what options the company really has to prevent or plan for flaring. I understand that assuming you cannot flare might lead to a more complicated startup procedure, but shouldn't the procedure be correct? Shouldn't flare minimization be the goal? I don't want operators to get instructions not to use a safety device, but I also don't want it to become a regular thing. On page 10 of the report, in the table between 1300 on November 24th and 2000 to 2030, there is a soon after line item that is not clear when reading through the details of that on page 6. Basically, page 6 makes it sound like the decision to continue using propane was made but doesn't describe the conditional approach to the use of propane due to curtailment. For the footnote on page 13 that continues from continues to page 14 is confusing. Could it just be on one page? Number 5, page 14, the first sentence is misleading as the staff employee did not complete the 2 personnel required to perform the feed introduction. It should have been 2 qualified hourly operators. Number 6, page 14, paragraph 2, the last 2 sentences. Why isn't the decision to continue being challenged? Stop work authority is a worker's last line of defense. We should be challenging the systems and decisions that allow risk to reach the last line of defense. So I believe Ken-X spoke to other programs to address other stuff going on. So, you know, to get all that working and in place before it comes down to a worker using stop work authority, I think is a good idea. Number 7, page 15, the holiday, there's the tone in the second sentence. The console, this is what it says. The console operators who normally would have worked the evening shift took time off, leaving a shift supervisor and a production specialist to operate the CCU. So while this is factually true, I believe the tone of the sentence can be misinterpreted as blame on the workers who took time off, missing the fact that they were approved to take time off and the decision to continue without them was made. So whose decision was it to use the operations specialist and team leader as board operators? This goes back to number 5 above, as well as number 6. There was a decision made to go forward. And lastly, number 8, in table 2 of the root causes on page 16, could we include an example along the lines of, for example, more operators, stuff like that. So when you're taking into account all these situational things going on, if there's a need for more operators, would that be proceduralized and captured right there in the procedure? That's all I got. Thank you.
Great, thank you, Nick. Okay, we'll move to Tony, and then in preparation for our public comment period, if you are a member of the public and would like to speak, please raise your hand now. Go ahead, Tony.
Yeah, just a couple of questions. Nick has the question about flaring. I want to make sure we follow up on that because I'm not sure I understand whether or not the flaring would have prevented the incident if they flared again. So, you know, the follow up on Nick's comment. Also, on the 4th stage separator, I guess the question is the alarms. Were the alarms going off? Were they silenced? How often are the 4th stage separator drained? And then I have a question to follow up on what Ken said. And this goes to maybe you, Nicole, and your team. Were you part of the interview process when the interviews were taking place? And if it wasn't said, how did it get into the report? You know, I mean, are you guys involved in the interviewing process so that there's a third party? And then for Scott, was there anybody who you wanted to interview that wasn't available to you? And let's see, just those kind of questions. I'll look for answers from either Scott or you, Nicole, or your team. That's all I have.
Great, thank you so much, Tony. So I will address your question that was posed to Contra Costa Health. You know, this incident investigation root cause analysis is being run through the Oversight Committee as an independent third-party analysis. So while we were present on site for the follow-up meeting to confirm some of the technical items, Contra Costa Health did not participate in the interviews with Scott, nor did they participate in any other portion of the work that was done on this incident investigation report outside of that site visit in November. Okay. I see that we have 4 members of the public who would like to speak. Again, in our public comment period, we allow members of the public 2 minutes to speak. If you would like to speak, please raise your hand so I can ensure to call on you. I do acknowledge that we are getting close to our end time, but also due to our technical difficulties, we started late. So if the members of the Oversight Committee are able to hang on for just 10 more minutes, I'd like to extend this meeting to 12:10. And I will go ahead and start with our first community member, which is Jillian Elliott. And then I will move next to Tony and go down on my list. So Jillian Elliott first, and then Tony Hicks. Kayla, if you could please promote Jillian.
Yes, Julian, go ahead.
Thank you. This was very informative, and I appreciate this being public. I have also want to, thank especially Ben and Nick for your questions. I have some that are related that I would like addressed, and I know it's going to be over time, but I know that the report talks about mostly, or what was talked about today is mostly human error, human fatigue, process problems, and certainly it would be cheaper for them to have to do that, to revise processes and hire people than it would be to make mechanical improvements to the refinery. But I'm wondering if there was actually an inspection of all of the refinery, the slider and everything else, because without that, I don't know that we can say it was only human error or process error. And also, I would like to ask whether we are supposed to assume that these would be the same problems for all of the flaring and other 40 plus violations since this accident. And I don't know that we can do that without really looking at the refinery itself and not just the processes. Thank you.
Thank you, Jillian. So just as a reminder, as part of our process, we are going to have that public notice beginning at the end of February with the 45-day public comment period. So I'm going to move on to our next speaker of the public, and we will have no responses from Scott at this time. You can officially resubmit those comments at that point in time, Jillian. So thank you. So we'll move next to Tony, and then after Tony, Alicia.
Tony, go ahead and come off mute. Your 2 minutes starts now. Oh, there you go.
Hi, this may have already been covered, but is this preliminary report available where I can take a look at it?
This report is not available at this time. Our process is to post the recordings of this meeting along with meeting minutes and any presentations on our website. And so there will be more information coming along further. Okay. And when we open that 45-day public comment period, we will have another draft report also available on our website to the public.
Okay, so no executive summary or anything like that?
Not posted at this time. Thank you.
Okay, thank you.
Alicia?
Hi, my name is Alicia G'day from Healthy Martinez. First, I'd like to make the request that materials do get put out in advance.
Sorry, that was my fault. Go ahead, Alicia. Sorry, I did not mean to cut you off.
Okay, am I on now?
Yes, we can hear you.
Okay. Oh, sorry. My name is Alicia G'day, and I'm from Healthy Martinez. I just like to make a request that when there are materials that are going to be talked about in a meeting like this, that they do get put out to the public, because it puts us in severe disadvantage to be the only ones in the room who haven't had access to those materials. Secondly, I would like to ask, and I hope this can be addressed now, how does the recent investigation that was initiated by County Health in late December relate to what we're hearing about in this report? Is that investigation, and I believe it's ongoing, is that reflected in that report? And if not, how will that investigation be shared with the public? And then it sounded like there's just a brief mention that the PHA had failed to accurately identify the consequence severity level by Shell and then also by MRC. That sounds like a really big deal, and I'd like to know how that failure to classify is going to be addressed, and that did not seem to be included. Thank you.
Thank you, Alicia. So all comments again related to the incident investigation report, we will need to have those officially submitted as part of the 45-day public comment period when that opens at the end of February. However, I will address your question as it relates to the unannounced inspection that was started by Contra Costa Health on December 28th. So the difference between these two activities is the work that Scott has done for us is an independent incident investigation and root cause analysis for a specific event. And that event is the November 24th, 2022 spent catalyst release. So Scott was focused on the catalytic cracking unit, the resulting release of 24 tons of spent catalyst into the community, and investigating why this happened and making recommendations to prevent something like this from occurring into the future, and recommendations for those root causes. The unannounced inspection that was done by County Health is to look at specific safety program elements as they relate to our county's industrial safety ordinance and corresponding state regulation known as the California Accidental Release Prevention Program. Based off of safety concerns from incidents that MRC has had, including the two major chemical accidents and releases, the November 24th, 22 event and the December 2015, 2023 flaring and odor event. The team has gone in, identified specific safety program elements that they will be evaluating, and this is looking at those program elements from a refinery-wide basis. So they are two separate activities. So that activity of the unannounced inspection is not incorporated into Scott's presentation. We did post on our website 2 weeks ago a status update which detailed what program elements the team was looking at and what they had looked at to date. And we will be posting on our website the final unannounced inspection report when it is completed. Work is ongoing, and that will be communicated, out again through our constant contact list. So I'm going to make one more plug on this one, and I will put that website in the chat. If you would like to, stay informed of what is going on with MRC, you can always visit our dedicated webpage, and please join that constant contact list. All right, next we'll go to Maureen, and then I see Greg Karras as our last member of the public with their hand raised. So Maureen?
Thanks. I'm curious about, Ben mentioned, had the stripper valve been inspected? And I'm curious because the Southern California incident that occurred indicated that the stripper valve was stuck or damaged in some way. So I'd like to hear about that inspection. And also regarding that valve, if the manufacturer's protocol says do not use in manual mode, end of story. I don't know what happened there. The opacity event is interesting. Why was that ignored? The original root cause report a year ago said there was no opacity event indicated, yet in today's report it says it was high, but no action was taken. I'm curious about that because that's the indicator of release from the stack. Let's see what else. And I'm really concerned that PBF did not notify the community resources. And according to their report a year ago, it says because there were no calls from the community, that is unacceptable. The community should not be responsible for making that notification. And that's up to the company to be doing that. But because there were no calls from the community, they did not act. I suppose that's not a root cause, but it needs to be addressed. And also the thing about the 20-hour shift is shocking to me. I come from the healthcare industry. Decades ago, we ended, interns and residents used to do 20-hour shifts, and it was clear that at the end of their shift, they couldn't think anymore. They couldn't make good judgments. So that's very unacceptable. I think
20 seconds.
Okay, we'll call that enough for one day. Thanks.
Great, thank you. And we'll move on to Greg Karras.
Greg Karras, Community Energy Resource. I'm working with the Healthy Martinez folks. So these comments are going to appear a bit harsh, only partly because you're only giving 2 minutes on a report that you haven't shown the public. Clear refinery management failure to shut down upon emergency unsafe conditions needs to be clear. The county needs to be clear about that. This report, as I've heard it so far, is burying that lead in a way that it will never, they will unlikely be held accountable for it since that authority is already required. They didn't do it. You need to say it. The report needs to include very explicitly inherent safety analysis of the explosion hazard from the ignition source that was part of the incident, and the air district's findings of feasibility for wet gas scrubbers. That needs to be in the report. That's part of what the incident evolution was. Excluding it is just ducking the issue. And this is not about the report. This is a public, this second one, the slide valve testing. I agree with all the comments about it. I made the same request informally to the county in November. You heard it in December.
You have 20 seconds.
And you heard it again. Don't stonewall on that. Give us that information. Don't use this committee to stonewall that. I agree with the USW comments on the slide valves, the flaring, and the shutdown. Please get this together. Stop making it look like you're helping them hide the ball. That's it.
All right, thank you. Before we move on to Michael Kent, who appears to be our last member of the public who wishes to speak, I do just want to reiterate that at the end of February, a public comment period will be open for 45 days, at which time a report will be made available to the public on this incident investigation root cause analysis. Okay, Michael?
Yeah, hi, can you hear me okay? Hello? Can you hear me?
Yes, sorry, Michael, we can hear you. I lost my screen for a minute, but yes, you're coming through loud and clear.
Thank you. Michael Kent, I'm the Ombudsman for the county's Hazardous Materials Program. I had a quick question for Scott. You mentioned that the opacity meter, I think this is what you said, didn't record the event, at least the massive amount of catalyst going through because it had already hit its highest level. So could a contributing factor to the event be that the opacity meter couldn't measure higher levels of releases? And if so, could a recommendation that, a different opacity meter would make a difference? And then I guess overall, my question, because I'm not sure, having not seen the report yet, I understand completely all your recommendations, but if this incident were to happen again in the same way, were the recommendations for alarms and other measures you put in enable the facility to know that this release was happening if this sort of thing happened again? So those are kind of my two questions. Thank you.
Thank you, Michael. I just want to do one last call to see if any of our members from the public would like to make a comment before we hit that 12:10 stopping period. Okay, I do not see any additional hands raised, so I will go ahead and conclude this meeting of the Oversight Committee. Again, part of our next steps, I will be working with Scott Berger to incorporate the Oversight Committee's comments that were submitted. And then we look forward to opening our public notice period and having that 45-day public comment period in public meeting. So thank you everybody for participating today, and I will talk to you all next time.